Okay, number 2. Air enters a partially open valve inside a ventilator. A steady state flow of air is used to keep a patient's lung open at 5 centimeters H2O pressure. The work rate required to keep the patient's lungs open is 1.9 kilowatts or kilojoules per second. If the inlet air temperature is 15 degrees Celsius, what is the required mass flow rate of air? Assume ideal gas for the air and standard body temperature for the patient, neglecting kinetic/potential energy effects and any stray heat transfer with the surroundings. So, because they mentioned all these factors and how they don't matter, I am convinced you have to use the energy rate balance equation at steady state mentioned here. Because at steady state, this will be 0. And there's no change in energy in steady state. This is negligible. There's only one mass flow rate because it's steady state, and these also cancel out. Move everything around. Your final formula for mass flow rate would just be the work dot control volume given to you over the change in enthalpies. So we're going to do one final interpolation using the two temperatures. So T1 is 15 degrees Celsius. Go to table 822, get your enthalpies. In terms of Kelvin, 15 degrees plus 273, that's 288. This is the H, the enthalpies. Units are kilojoules per kilogram. 285, 285.14. This is not going to be a very impressive interpolation, let me tell you. 290, it's going to be 290.16. I already see a trend happening. So X is equal to H1, which is equal to 288.15 kilojoules per kilogram. Now T2 is stated to be standard body temperature of the patient. I Googled this value, so it must be correct, and that is 37 degrees Celsius is the average body temperature. So you don't have to do interpolation for this. You just look at 310 Kelvin on the steam table, and you should get 310.24 kilojoules per kilogram. Now we have to talk about the sign convention of this work dot. We were told it was 1.9 kilowatts, but whether or not it's positive or negative, I believe depends on the system you're evaluating. If it was the ventilator, then that would mean the work is done by the system to keep the lungs open. So your work dot would therefore have to be positive 1.9 kilojoules per second. But if your system was the lungs, you're doing work on the system. I have to be careful of what my phrasing here is. So your work would be negative to keep the lungs open. I'll be using this lung system work doc just because I believe it makes more sense to explain the positive mass flow rates conceptually. So mass flow rate will be equal to the numbers we found, negative 1.9 kilojoules per second. H1 minus H2 minus H2 include units, make sure they cancel out properly. So cancel. And your final mass flow rate will be 0.086 kilograms per second. So this is the mass of air per second that's entering the lungs. And that's how you do number 2. That is the last question I'm doing for thermo. I had a great semester. I believed I learned a lot. And thank you for watching.